welcome back. Today is statistics, day 8. These notes are going to be very short, especially since you need to look at the graphing calculator to do a lot of these problems. So we will look at them in more detail tomorrow in class. But today we're talking about nonlinear regressions. We have different types of regressions, like I said in class today. We have one that's exponential, and it's an exponential curve that does not pass through the point 0, 0. This is huge. That's very important. Exponential functions do not go through the point 0, 0. So the y-intercept is positive, and my data constraint means that y must be greater than 0. We have logarithmic regression, and logarithmic can look like exponential sometimes or power regressions. But the key again here is logarithmic does not go through the point 0, 0, and the y-intercept is positive or negative, and my data constraint is that x must be greater than 0. For a power regression looks a lot like exponential and also a lot like logarithmic. These two sort of match here, and these two sort of match here. Here is the deal. They can go through the point 0, 0, and my data constraints are x and y are both greater than 0, 0. Okay, they will actually go through the point 0, 0. The positive half of the power curve will go through that. We have other regressions, which are quadratic, which will look like a parabola, either opening up or down, and cubic, which looks like an x cubed, y equals x cubed graph. Okay, so we have some examples here. I already have them done for you, but I'll just kind of walk you through them. A stone is dropped from a height of 1,000 feet. The trajectory of the stone is recorded by a high-speed video camera in intervals of a half second. The recorded distance that the stone has fallen in the first 5 seconds is given below. So this top list is L1, which is x, and our L2 is our distance. So we would put this into L1, this into L2. And we would need to decide which regression is most appropriate. When we actually look at the scatter plot on the calculator, it looks like it could either be a power or a exponential. But the reason that this is power is because time can be 0 and distance can be 0. So we can be at the point 0, 0. So on our calculator, once you've entered the information in and you've looked at the graph to determine what you want, hit stat again, calculate, and go down to letter A, and it's PWR regression, power regression. And you have to do L1, L2 again. And sometimes it helps to put the y1 in there so that you can see it over the graph. And when I do that, I get y equals 13.619 times x caret 2.122. Okay, that's fine, but I want to see this notation on your test. Don't use the caret. You guys are big kids now, so actually write it as an exponent. It makes the equation look a lot nicer. And see, it says nearest thousandths, so that is 3 decimal places up. In example number 2, a pediatrician has the following table that lists the head circumferences for a group of 12 baby girls from the same extended family. The circumference is given in centimeters. So we have our age in months, which is our L1, and the circumference, which is in L2. Make a scatter plot of the data, which we will do using the calculator so you can see what it looks like in class. Choose what appears to be the curve that best fits the data. This one looked like it could be a power or a logarithmic regression. You won't see log regression on the calculator. You see natural log, so you're going to look for ln. The reason why this can't be a power regression is because it needs to go through the point 0, 0. This cannot happen because there is no time 0 and head circumference of 0. That would mean the instant they were born, they had no head. So you have to be careful with that. It's not possible to have both the age and the circumference being 0. So 0, 0 is not an option on this graph. So we need to do, after we get our information into the calculator, And after we've looked at our graph, we need to do stat, calculate. We want number 9, and that's LinReg, okay, logarithmic regression. This is the equation, and I did write down my R value for you so you could see. You could try the power and the exponential, and you would see that they wouldn't come close to getting R value that close to 1. So this is a pretty strong regression here. And that's really it. We're going to practice more in class so you can see with the calculator what's going on. But it's just a matter of looking at the picture of the graph and determining what the shape of the graph is, and then determining which kind of regression you want to use. Again, power goes through the point 0, 0, exponential and logarithmic cannot. So you have to ask yourself, even though it looks like those graphs, which one can it be? Okay? Like I promise you, short notes tonight. We will work on this again in class tomorrow.